Hi everyone, so by now you've actually watched a review video on trigonometry from geometry that you learned, and also a review of the 45-45-90 triangle and the 30-60-90 triangle. So this is the topic in trigonometry. There's a set of videos that are going to go with every set of notes, and then practice will go along with that. So let's just review really quickly Sohcahtoa. Every point in the plane makes a triangle, right? I can take any 3 points, and if I connect them, as long as they're not on a straight line, then I can create a triangle, okay? Then, once I've created a triangle, it will create 3 angles, one of which, for this unit, for trigonometry, would have to be right, okay? So it would have to be in a right triangle. All right, and then the relationship that you learned about is that angle that it's created, let's talk about this angle right here. We might call it theta, we might call it x, or we could even call it angle A or angle BAC if we wanted to. All right, so if we're trying to find the angle, that angle is created based on a ratio relationship between either its opposite and its hypotenuse, or its adjacent and its hypotenuse, or its opposite and adjacent. And these are the trig ratios that allow us to create an angle or to find an angle given a ratio. So sine of the angle is the opposite over the hypotenuse, so that's our SO. Cosine of the angle is equal to the adjacent over the hypotenuse. And tangent of the angle is the opposite over the adjacent. You should have learned this in geometry. If you did not, the previous unit, let me know, and I can actually make sure that you have a unit on just the basics of right triangle trig, because this is review. All right. So what if we want to find the side length of a right triangle? So I give you a right triangle, I have a 24-degree angle right here, and an x and a 20. So based on that angle, I figure out what I have and what I'm looking for. So I have the adjacent leg, I want the opposite leg. So that would mean I'm going to use the tangent ratio. So then I write an equation. Tan 24 equals x over 20. All right, to solve this equation, I multiply both sides by 20 degrees, or 20, sorry, not 20 degrees, 20. And that would give me 20 tan 24 equals x. All right, so then I grab my calculator, and then I do 20 tan 24, and I did not get what I wanted, so, okay. And I get 8.9 degrees. I'm sorry, 8.9. Not degrees, it's a length, sorry. Okay, now if you didn't get 8.9, that means your calculator is probably in the wrong mode. So if you look right next to the second button, you'll see the word mode. If you go down to line 3, you want degree to be highlighted, not radian, okay? All right, so let's look at the other one. The other way we could ask, we could actually be looking for the angle. If I'm looking for the angle, then I use the trig ratio to find the angle. So first I write my equation. So I have my opposite, I have my adjacent. Again, I'm using tan. So it would be tan of the angle, so tan of theta equals 24 over 32. Okay, anytime we need the angle, we have to use the inverse because we're working our way backwards. We're undoing the ratio, right? So need angle, use inverse. I use the mnemonic NOWI to help me remember that. So I'm going to use the inverse function on my calculator. And so second tan 24 divided by 32, and I get 36.9 degrees. If you did not get 36.9, remember, you could be in the wrong mode, so make sure you're in degree mode, not radian mode, okay? All right. So that is a little review. Last night you also reviewed the special right triangle relationships, the 45-45-90 triangle, making sure you understand it's an isosceles right triangle. Really important angles we're going to be using this in this unit. And the 30-60-90 triangle, another really important triangle you learned in geometry that we're going to be using in this unit. I want to make sure you understand that in the 45-45-90, if you have 2 legs that are equal, then whatever that value is, the hypotenuse will be that number root 2. Now you have to be careful if it's a whole number. So if I gave you, I don't know, 4 as the hypotenuse, to get back to the legs, you would divide by root 2. and then you'd rationalize, and you get 4 root 2 over 2, which is 2 root 2. Now, a few students in class have noted that if you're given a whole number for the hypotenuse, then the legs are going to be half that number, root 2. And that's true. All right, 30, 60, 90. We call we call the side opposite 30 the short leg. So you always have to pay attention to where the 30 degree is. We call the side opposite the 60 degrees the long leg. And obviously, the side opposite the right angle is the hypotenuse. And so it's important to recognize these two, that it's short leg times 2 is the hypotenuse, and the short leg times root 3 is the long leg. All right, so you had some practice on that. The answers are posted for you. If you have any questions, please reach out. All right, so we're going to take it and move into our current work. I want to practice this. I want you to realize what to do if you have a triangle that has a hypotenuse of 1. Okay? So if this says 45, then I know this is a 45-degree angle. And so to find each leg, I would take 1 and I would divide by root 2, and then I would rationalize, giving me root 2 over 2. So each of the legs would be root 2 over 2. It does follow that pattern that it's half the hypotenuse, root 2. So I'm happy if you understand that. All right, in this 30, 60, 90 triangle, if my hypotenuse is 1, that's the 2a. That means that my short leg is going to be 1/2. And that means that my long leg is going to be 1/2 root 3. Now, we actually don't write it like that. We're going to rewrite that simplified form, root 3 over 2. All right, so now these triangles we can find the ratios without a calculator for these particular ratios. So if I want the sine of 45, that's going to give me opposite over hypotenuse, so root 2 over 2 over 1, which would just give me root 2 over 2. All right, the tangent of 45 would be the opposite over the adjacent. So that would be root 2 over 2 over root 2 over 2. Same value over same value, 1. The cosine of 45, all right, so that's going to be the adjacent over the hypotenuse. So that's also going to be root 2 over 2. Those values will always be true. If I ever ask you the sine of 45, you're going to have to know it's root 2 over 2. So these values are going to be things that over the next couple of days, we're going to want to memorize, okay? All right, let's go to this triangle with 60. The cosine of 60, okay? So the cosine would be 1/2 over 1. So the cosine of 60, would be then 1/2. All right, let's look at the tangent of 30. Tangent of 30. Tangent would be 1/2 divided by root 3 over 2. Oh, that's yucky. So now we have to keep change flip. So 1/2 times 2 over root 3. We have to simplify. So 1 over root 3. And then we rationalize. And we get root 3 over 3. Cosine of 30. Cosine of 30. Okay, so the cosine of 30 would be root 3 over 2 over 1. So that would be root 3 over 2. Oh, goodness. Sine of 90. Well, you can't really take the ratio. We never take the opposite over the hypotenuse of 90. But for now, if we do that, you're going to see opposite is 1, hypotenuse is 1, sine of 90 is going to equal 1. We're going to talk about that one in a couple of days, okay? All right, the sine of 60. Okay, so the sine of 60. So that would be the opposite over the hypotenuse, which would be root 3 over 2. The tangent of 60 would be the opposite, so root 3 over 2 over 1/2. We'd multiply by 2 over 1, and we would get root 3. Okay. All right, so those are the trig ratios that we're going to start to really recognize and know. These are called exact values. These are the values you're going to want to know. You're not going to be able to use your calculator on these angles. So hopefully this was a helpful video. You're going to go on to video number 2. Have a great day.